The diagnosis of Parkinson's disease, PD, still relies largely on the onset of motor symptoms, by which time substantial neurodegeneration has already occurred. This limitation highlights the urgent need for biomarkers capable of identifying the disease during its prodromal phase, when disease-modifying interventions may be most effective. Because PD is causally linked to the misfolding and aggregation of alpha-synuclein, considerable effort has been devoted to evaluating alpha-synuclein as a biomarker. However, measurements of free alpha-synuclein in plasma or serum have yielded inconsistent and often contradictory results. In this context, neuronally derived L1CAM, positive extracellular vesicles, L1EVs, have emerged as a promising source of biomarkers, as they may mirror pathological processes occurring within the nervous system. In this study, Tafaris and colleagues developed an ultrasensitive microfluidic platform for the detection and quantification of EV membrane-associated proteins at single EV resolution. The assay combines immunocapture of L1EVs with on-chip droplet compartmentalization of individual EV bead complexes, enabling the analysis of rare neuronal EV populations from minimal serum volumes. Using conditioned media derived from neuroblastoma cells expressing alpha-synuclein mutants, as well as iPSC-derived neurons from a patient carrying an alpha-synuclein gene triplication, the authors demonstrate that membrane-associated alpha-synuclein is increased under pathological conditions. They further show that this association is partly determined by the membrane-binding affinity of PD-associated mutations. Notably, the authors show that membrane-associated alpha-synuclein distinguishes both patients with PD and with isolated REM sleep behavior disorder, IRBD, from healthy controls with high diagnostic accuracy, AUC greater than 0.93. Since IRBD is a prodromal stage of alpha-synucleinopathies, this finding suggests that the biomarker may identify disease-related changes before the onset of classical motor symptoms. Furthermore, by employing antibodies recognizing either monomeric or aggregated conformations, the authors demonstrate that a fraction of membrane-associated alpha-synuclein displays pathological features. Overall, this work identifies L1EV membrane-associated alpha-synuclein as a promising blood-based biomarker for early alpha-synucleinopathy and introduces a powerful technological platform for its detection.